All right, welcome. Today you guys have a sub. It's Wednesday, October 21st. Here's our agenda for today. We have no homework that's due. Your vocab retake should be in Infinite Campus. If you took those, Monday was the deadline, so I got all of those graded and they should be in there. The study guide for the exam that we have on the 27th, which is next Tuesday, will be 5 points extra credit. It is on Google Classroom. On Google Classroom, it's going to be right here under this Rocks and Minerals test. So you know where that is. You're not required to do it, but again, it's 5 points extra credit. After we're done going through this, you guys are going to have about 7 minutes to measure your crystal growth. So don't get up yet, but you guys will all go into the back. There's not going to be any heating or remaking of crystals today because I'm not there, and it might not be safe. After that, we have a video lecture on metamorphic rocks, and then we're going to explain how to do the metamorphic rock lab, and you guys will break out into your lab groups to do that. And then when you're finished with that, if you have extra time in class, you can start on section 3-4 metamorphic rocks review. It will be your homework if you do not get to it or do not get a chance to finish it. So, coming up next, I guess it's time to measure our crystal growth. Please remember to put it in your data table. You need the mass, the length, and any other descriptors. Please put the date in. Again, there is no heating or no remixing today, so you're just going back and taking observations. We are going to resume in about 7 minutes. You should be back in your seat, ready to take notes. You guys are halfway through your time. Please make sure that in another 3 minutes you're cleaned up and back in your seat ready to take notes. In about a minute and a half, you need to be back in your seat ready to look at notes. Please make sure your area is cleaned up. Be heading back to your desk. Alright, so you've had some time to measure your crystal. You should have gotten the mass and the length and noted any other features of that. Now we're going to take these video notes on metamorphic rocks. This can look like a lot of different things. I give you guys a lot of flexibility on note taking. You can take notes on your device. This has been shared in Google Classroom under 024 Metamorphic Rocks, so you can pull this up and take notes right on the PowerPoint. You can take notes on a piece of paper. It's not okay to sit and be talking to your neighbor, and it's not okay to be doing nothing. So please pull out whatever it is that you take notes on, however you're going to take notes, and get that ready. After this, we're going to explain how to do the Metamorphic Rock Lab, and then you guys will go back to the lab stations and begin that. And then you'll have Section 3-4 Metamorphic Rocks Review homework if you have not finished it yet in class. So, metamorphic rocks are going to be rocks that change. We haven't done any of the reading on this yet, so this is going to be kind of your guys' first preview. We did kind of look at it when we were talking about the rock cycle, though, so not the first time you're hearing of it, but the first time we're really delving into it in this class. These are our objectives from the rock cycle. So as per standard, we're going to go over all of our objectives from our lectures before we begin. I want you to pick one of these right now. Each partner pick a different one. And you're going to have about 45 seconds each to share with your partner. So for example, if I pick what are the 3 major types of rocks, I would share with my partner in 45 seconds, and then my partner would pick a different one and tell me what the answer is. All right, 45 seconds. We're answering 2 of these today. Five, 4, 3, 2, 1. You guys should be familiar with these. We've been doing these every day. Same thing for igneous rocks. Let's just have one partner pick one of these and explain it to the other partner, and then the next partner will pick one of sedimentary rocks. So we're going to do 30 seconds to explain one of these 3 objectives to your partner. Five, 4, 3, 2, 1. For these, I definitely think that this differentiate between intrusive and extrusive is going to be our take home. Remember again that intrusive is inside and it cools slowly, so it has large crystals, and extrusive is outside, so it cools quickly and it has no crystals or very small crystals. The next partner is going to do one of these. These are the objectives that we talked about on Monday. So whoever did not talk for Igneous Rocks is talking now. Please pick one of these 2 and describe it to your neighbor. 30 seconds, go. Five, 4, 3, 2, 1. All right, so describing how sedimentary rocks form. Hopefully you remembered the WEDCC, weathering, erosion, deposition, compaction, and cementation. And then our 3 major types are clastic, organic, and chemical. You should have been able to describe those. Here's our objectives for today. 3 things that you should walk away from this lesson knowing. Previously, we've talked about how in your notes these make good section headings, so you can just take notes right under these objectives and you know exactly what you're looking for. Today we need to be able to differentiate between contact and regional metamorphism. Identify the 3 agents of metamorphism and describe them. And finally, explain how metamorphic rocks are classified and be able to separate rocks into classification groups. This second half right here, and be able to separate rocks into classification groups, is going to be directly correlated to our lab. So in the lab, you're going to be able to do that. So maybe just write, explain how metamorphic rocks are classified. Okie dokie, carrying on. So the formation of metamorphic rocks is the first thing that we're going to talk about. One of the key words here is metamorphism. It was not one of your vocab words, but it literally means to change form. Everyone say metamorphism. Everyone say to change form. So metamorphism is to change form. How these rocks change form is we have high temperatures and pressures beneath the Earth's surface, which is going to make any of our pre-existing rocks, so sedimentary, igneous, or an already metamorphic rock, and it's going to cause it to change into something else. These three down here are examples of already metamorphosized rocks. We've got some gneiss over here and some slate, so when our rocks are feeling under pressure, they change into something else. There's two ways that rocks can go about this. The first of which is contact metamorphism. If you think about it, it's just like it sounds. Contact. If you're playing contact football, what are you doing to the other team? Well, you're touching them. So contact metamorphism means it's coming in contact with the rock, and it's going to be on small scale because it actually has to touch it. So in this picture right here with our contact metamorphism, our magma is radiating off the heat. This is not where contact metamorphism is occurring, because this is just melting the rock, so this is turning it into magma. But around the edges out here, where this light colory see-through red is going to be where our contact metamorphism is occurring. Some common rocks that form like this is marble, which we use for headstones at the cemeteries, and the statue of David, I think, was made out of marble. So this is our contact metamorphism. The other type of metamorphism we have is regional metamorphism. It's going to happen over large areas, and rocks are going to be subjected to extreme heat and pressure. Regional, like a huge region, so over a very large area. This usually happens because of plate tectonics. So when you have two plates, that push into each other, it's going to create all this deformation in here, and it's going to have heat and pressure, and it's going to cause that rock to change. One of the largest areas of regional deformation is actually in Colorado. If you've ever been down to Gunnison, which is southwest, they have the Black Canyon, and the Black Canyon is an excellent example of what is regional metamorphism, or large areas subjected to extreme heat and pressure. Here's a picture of our plate tectonics. So our regional metamorphism is happening up here where the mountain is getting builded when these two plates are pushing. So this plate is pushing in this way, and this plate is pushing in this way. The one plate subducts or goes down and melts. Anywhere that there's this magma around here, we're going to have contact metamorphism. But as these plates are pushing, this mountain range is getting heat and pressure on it. So it's going to be over the entire region. We'll have some regional metamorphism. And then down here along the subduction plate and the magma, we're going to get more contact metamorphism. So they can happen in the same kind of areas, they just happen differently. Agents of metamorphism, there's three of these. This goes under our next objective. So far, we have differentiated between contact and regional metamorphism. Take 30 seconds quickly to explain the difference between contact and regional to your elbow buddy. Go. Five, 4, 3, 2, 1. So now we're on our next objective, identify 3 agents of metamorphism and describe them. So our first agent of metamorphism here is going to be A, heat, which comes from magma or lava. This allows the minerals to move around and or recrystallize. So sometimes they change into new minerals completely, which is why it's the and or. So they either move around and recrystallize, or they can move around or recrystallize, meaning they're turning into something completely different. So different minerals and rocks can stand different temperatures. For example, silicate minerals, which we know are our most abundant group, can withstand more heat and pressure before changing than other types of minerals. So they have to be buried deeper in the ground and experience higher temperatures and pressure before they change. Our second agent of metamorphism is going to be pressure. Pressure is going to squeeze the rock, changing the density and alignment. This is where we're going to get our vocab words foliated and unfoliated. Foliated meaning striped or banded, and unfoliated meaning not. So this is an example. Up here we have our mineral crystals, and then through pressure they're going to get flattened out, squished. They're going to become more or less dense. What do you think? They should become more dense because all of our particles up here are now occupying less volume, and density again is mass over volume. So far we have heat and pressure as agents of metamorphism, causing our rock to change. Our third type is going to be reactions in solution. For this, we'll have hot fluids promoting recrystallization by dissolving the original materials and then depositing new ones. So in these hot solutions, the magma will heat up nearby water, and then the hot water is going to be moving more quickly, the particles in the hot water, than the cold water, which will initiate some minerals to dissolve, and that can totally reshape the metamorphic rock or rock type into something new. So now we have answered. Identify 3 agents of metamorphism and describe them. Please tell your elbow buddy the 3 agents of metamorphism and describe them. 45 seconds on the clock. One person can go, and then the next person can do the next one, and then the next person can do the next one. 45 seconds, go. Five, 4, 3, 2, 1. Now we're going to tackle our last objective, which is explain how metamorphic rocks are classified. And then back in the lab, again, you'll be able to separate them into their classification groups. So our metamorphic rocks are classified into 2 groups called foliated and non-foliated. In foliated metamorphic rocks, which was one of our vocabulary words, we know the minerals have a line to show pattern. Specific minerals in the rocks can align, so that's what this mineral alignment means right here. You can kind of see it in this sample of gneiss. The pink feldspar minerals are aligning, and the black basaltic minerals are aligning. So we have specific mineral alignment. And then bonding means that they're bonding into flat sheets. A really nice example of a foliated metamorphic rock that has good bonding is actually mica, which is that clear, see-through, shiny one that we looked at the other day. This one also has nice bonding. You can see the sheets and how it looks foliated. Our non-foliated rocks will not show a pattern at all. Both of these have no pattern, so this is marble and quartzite. And we can file marble down so that it's square and it looks really nice, but in nature, this is what it looks like. You guys might have marble countertops at your home. I don't know if they make those anymore. They used to. And then this is quartzite. Quartzite also has a frosted appearance, but it's not quite as frosted. So those are our non-foliated metamorphic rocks. All metamorphic rocks will fall into those categories, foliated or non-foliated. So here's our animation of our metamorphic rock formation. You have this igneous rock and heat and pressure. If you watch these crystals up here, you'll see what happens when we get heat and pressure. So our grains are going to be aligned, they recrystallize, and we're going to have a foliated metamorphic rock. Here's a couple examples of the metamorphic rocks we were talking about. This picture is from Black Canyon in Gunnison. I told you guys that earlier at the beginning of this class. If you ever get a chance to go there, you should. It's only like 4.5 hours away. And you can see all of these foliated striations in this giant metamorphic rock. So this used to be a mountain range, and as the plate tectonics collided or squished together, all of this rock underwent heat and pressure changes and turned into giant metamorphic rock. This is the largest scale metamorphic rock in the United States. Here's another example from Norway. You can see the foliation here. Same type of thing happening. This is a topographic map of Norway. This is going to be where your mountain range is. So as this plate collided with this plate to make the mountains, the sedimentary rock inside underwent extreme heat and pressure. Another example of regional metamorphism, and created these really cool foliated looking rocks. Here's Norway up here, map just in case you weren't sure. So that answered our third objective, explain how metamorphic rocks are classified and be able to separate rocks into classification groups. Please explain this last question to your elbow buddy for the next 30 seconds. Go. Five, four, three, two, one. All right, we are going to switch gears after these notes. Oh, we're not going to do that. We're going to switch gears after these notes. You guys need to take out your lab notebook. Hopefully on Monday we finished our sedimentary rock lab and our igneous rock lab. Even if we didn't finish them, we'll work with them on Friday. Today we are going to turn to our metamorphic rock lab in our lab notebook. All right, so we are going to do with the next portion of class is a metamorphic rocks lab. You should have all of this copied down into your lab notebook. If you do not have it copied down into your lab notebook, you know who you are and you know the alternate assignment that you need to be working on. We talked about that last class. So in our lab notebook, we should have already done, we did these two things on Monday. So we did the sedimentary rocks lab on Monday, and you filled this out. And then also we did the igneous rocks lab on Monday, and you should have filled this out. I'm making this on Sunday evening, so if we didn't get to that, we'll finish it on Friday. But today we're going to do metamorphic rocks. In your lab notebook, you should have the title Metamorphic Rocks. We need to do a problem. It's going to be the same as the problems that we did for igneous and sedimentary rocks. So under or near problem, we are going to put to identify metamorphic rocks. So our problem today is to identify metamorphic rocks. We are going to use a bunch of tools in our tool bags to identify the samples back there. This you should not have on your lab sheet. It's from something else. So procedure. Today you will examine each rock sample. You're going to use the hand lens to note the characteristics of each rock, including color and texture. So in the back, there's a hand lens at each station. We use the hand lens on Monday to look at sedimentary rocks. You're going to use the hand lens to look at color and texture. You will also note the size of the mineral grains and look for evidence of mineral layers. We just learned about the two classifications of metamorphic rocks, foliated and non-foliated. So you're going to look for that foliation or non-foliation. Based on your observations, then you will decide which rocks are not metamorphic and which ones are. The ones that are not, you are going to have to tell if they're igneous or sedimentary. Some indications of metamorphism. They're going to be very dense. They might have that sparkly look if they're non-foliated. They're going to be foliated or striped if they are, and dense. You will identify each of the rocks based on pages 83 through 84. Or, last class, we glued in this right here. So you should have this dichotomous key in your lab notebook. You can also use this to identify rocks. You will use the information in the text to help you decide which non-metamorphic rock is the parent rock for each metamorphic rock. You should be prepared to defend your decisions. So in your lab notebook, you should have this data and observations. Every time we have a data table, we need to make a title for it. So let's go ahead and put a title in there now. If you didn't leave enough room up top here, maybe write it off to the side, going sideways. So this is going to be what would be a good data table for this. Characteristics for rock samples. Cool. Over here it has the rock samples 7, 4, 9, 8, 15, 16, 13, and 12. The numbers are on each of the rocks in the back. However, if they've rubbed off, I'll have a picture up here of what they should look like. The first thing you're going to do after you've examined them with the hand lens and took note of the color and texture in your brain and looked at all of these things, we're going to start classifying them. Characteristics, foliated or non-foliated for metamorphic rocks, which means that your rocks that are not metamorphic are not going to be foliated or non-foliated, because you can't have a foliated sedimentary rock. It just doesn't work. We know that sandstone is a sedimentary rock 8. So for example, for number 8, we could put Na, because we're not going to have foliated or non-foliated for sandstone. In this category, you're going to put igneous, sedimentary, or metamorphic. You may use the internet to look these up. You can use your previous labs, Igneous Rock Lab and Sedimentary Rock Lab, to look them up. They're also in the book in Chapter 3. Oops, sorry, I went too far. Chapter 3 if you need to do that. So 15, 16, 13, and 12, we're going to have to identify all of this. I gave you the rock names for 7, 4, 9, and 8. The next thing that you're going to do is match the metamorphic rock with its non-metamorphic pair. So when we're dealing with metamorphic rocks, we typically call it like the parent rock and the daughter rock. If we were to line up couple of different people in here with their parents. Do you think that you would be able to tell who their parents were? Probably, right? And what type of characteristics are going to, what's the first thing you're going to do to figure out who's whose parent? Probably what they look like. So the same thing is happening here. We have our non-metamorphic parent rocks, and we're going to try and match it up with the metamorphic daughter rocks. We always call them daughter rocks. So you're going to be looking at characteristics that are similar amongst them. They might not be exactly the same. In fact, they're not going to be exactly the same because metamorphic rocks have undergone change, but we'll have similar characteristics, things that look alike. So here's a couple of parent and daughter rocks when we're talking about metamorphic and non-metamorphic rock. You guys are going to be matching these up in your lab, but I just wanted to give you a couple examples. So on the left here, we have our non-metamorphic rocks, and on the right we have our metamorphic. So when we're matching them up as to parent and daughter rocks, we're looking for physical features that look similar but may not be exactly the same. So the easiest one from these to match up is going to be this one right here with this. So our coal with our anthrolite, because they're both black. Although when this coal went under heat and pressure, it turned shiny and got more dense. These two obviously match up. The next ones we're going to look at are these two and these two. Make a hypothesis right now with your neighbor about which you think matches with which. So this metamorphic rock right here is Tiger's Eye, unpolished. You guys have probably seen these before. They're really pretty. It actually comes from a mixture of hematite and jasper, which is this. So these two would match. And then our phyllite is going to match this one over here. With practice, you'll get better at this. All right, so you guys have about 45 minutes left of class. You are going to work on that lab, the Metamorphic Rock Lab. I don't think that it will take you the whole 45 minutes to do that. Also, please be sure to answer the questions below. Oh, I think I lost that document. So you have just two questions to answer below. To find the names of the metamorphic rocks, you can use this dichotomous key, which splits into two every time. We talked about that on Monday. Or you can look them up in the book. After you're finished with that, you guys do have some homework. The homework is on Google Classroom. So here's Google Classroom. I have not yet posted the homework because it's Sunday. Where is it? So this is going to be your homework 025 Metamorphic Rocks worksheet, classwork/homework. It's a PDF just like we've been looking at. So if you want to open this with your Doc Hub and type on and turn it in online, you can do that. Or Mr. Menifee has a couple of copies of this, so you can just grab a paper copy from him. Please do not turn in anything today. If you finish, hang on to it until next class, and you'll turn it in next class. So in the next 45 minutes, our objectives are to complete the Metamorphic Rocks lab and then complete this worksheet that's on Google Classroom, or grab a paper copy from Mr. Menifee. I will collect all of these on Friday. Thank you, class. Have a great day.